I'm going to ask a series of dumb questions, which people have told me I'm well equipped to do. The first one is, give me a speed comparison between a ballistic missile and a hypersonic missile.
Let's see, hypersonic missiles go Mach 5 or above, and ICBMs are at, depending on altitude, Mach 10, 12, 13, something like 22,000 miles an hour.
So a ballistic missile is much faster, but a hypersonic missile doesn't go up and down. It goes straight. Is that correct?
The hypersonic missile follows a profile that's boosting and then reduces altitude into a longer glide phase and then a shorter terminal phase.
What's the range of a hypersonic missile? Could a hypersonic missile go from North Korea to the continental United States?
Yes, depending on the booster that's attached to it. It could range ICBM or intermediate range nuclear missile, or it can short range.
Does a hypersonic missile create a more difficult or a different targeting scenario for our missile defense for Fort Greely?
It's a different, and with the current sensor network that we have, a more difficult problem. And that's why the space sensor layer is so significant, so that we can capture it from the time it launches to the time we intercept it, birth to death.
And is North Korea doing any work on hypersonics, or is that just China and Russia?
I would need to discuss it in a classified forum, but the concern is potential, if not likely, proliferation.
And can hypersonic missiles have nuclear warheads?
Yes.
So this presents a really new challenge, and you say that the necessary step is additional sensors?
That is the first step, sir, to ensure we have custody.
And did I understand from the chair's question that those sensors, that new sensor layer is on unfunded priorities, not on the front burner?
It is on both. It is initiated in the Space Development Agency's budget to develop the architecture to support that sensor layer. But as my, if not top concern, near the top concern, it's my #1 priority in the Missile Defense Agency's unfunded list that was requested by the Congress.
It seems to me that's a very, very high priority, given the speed with which hypersonics are being developed by our adversaries.
Sir, I would agree, and I made a comment earlier that in my mind the enemy is time, not the ability of this nation to develop effective defenses against hypersonic threats.
General Graves, could you describe the recent test? Is that something you can describe here in an open setting?
Yes, sir. The reference is to the acronym FTG-11, Flight Test G, Ground-Based Mid-Course Defense 11, which together with the U.S. Northern Command and the U.S. and General Dickinson's team, we executed back on last Monday. It was the most complex, comprehensive, and operationally challenging test ever executed by the Missile Defense Agency.
And it was a success, was it not?
It was we are doing about 9 months' worth of data review because we collected lots of data, but the initial look says it was a complete success.
And define complete success. Did the bullet hit the bullet?
Yes, sir. The object of the test was to launch an ICBM, intercontinental ballistic missile, representative target, and we did that from the Marshall Islands out at Kwajalein to ensure it achieved the speeds you asked about earlier and the profile of a realistic threat. But this test was different because we launched within a very short period of time 2 ground-based interceptors, operationally released by the combatant commander using their operational processes, which is very important. And the lead interceptor intercepted the ICBM representative threat, but what's most important is that it created a debris field, and this test has been 10 years or more in the making, and the importance of that was the second interceptor was able to discern the debris from the next most lethal object, when I can talk about it in a classified forum, and also intercept that object. What that means is enemy concept of operations which seek to confuse our missile defense system by launching junk or debris would not be successful. That's why it was a success.
Congratulations. That's an amazing achievement to, I know, thousands of people,
Yes, sir.
Scientific, technological, physics, So please convey the heartfelt congratulations from this committee. One other quick question. Do we know if the North Koreans are developing a submarine launch missile capacity?
Yes, Senator, they are.
So that changes this calculation again. If they're launching their missiles from North Korea, that's one thing. If they're launching them from the Bering Strait or somewhere in the North Pacific, that's a different problem.
It changes the defense equation in terms of where the origin could be and what our other anti-submarine capabilities in a potential conflict, how they would be utilized. And it also changes the geometry depending on how the North Koreans could choose to employ that.
And the time.
Yes, depending on where they launch from. Yes, sir.
Thank you, Madam Chair.
Senator King.
Thank you, Madam Chair. Let me just follow up, and I apologize. As you understand, for some odd reason, the chairman and I aren't in charge of the schedule around here.
We should be.
We should be, yeah, it would work much more efficiently. But let me follow up. I was asking questions about could the capability of the North Koreans in a submarine. If a missile is launched from somewhere in mid-Pacific between Hawaii and California, would you still have time if it was a ballistic missile to target and hit it as successfully as you did the one coming from Kwajalein?
Senator, yes. That would be an intermediate range to short-range attack, for which our current systems, the THAAD system as an example, or if they're in the right position to defend a certain area, or the SM-3s that are carried on Navy ships as part of the Aegis weapon system, they would be positioned, and we've demonstrated the ability to counter those threats. The latest demonstration was last year with THAAD against an IRBM.
And so that deals with the shorter range, with
Yes.
the submarine launch, if that's the choice. Secretary Rood, talk to me about directed energy. One of the problems with missile defense is that the missiles that we're shooting are quite expensive. Where are we with directed energy? How far away are we? What the role might be? For example, could it be shipborne and do the boost phase? Give me a tutorial on where we are in directed energy.
Senator, I can begin, and then General Greaves and General Dickinson may have something to add to that as well. But the short answer would be, we are requesting funding to continue directed energy work that the Missile Defense Agency would lead. The main reason that work has, for ballistic missile defense, has been centered at higher altitudes, both for high-altitude UAVs or potentially space-based applications, is it's difficult to propagate lasers in the atmosphere. There's a lot of water, clouds, other things. And so by going up above the cloud layer or at a higher altitude or in space, that is a simpler
Then you have
challenge.
the problem of weight and
Yes,
sufficient
sir.
electric charge.
This is the engineer's challenge. Yes, if you optimize in one area, other parts of the trade space, you do encounter that. But it is easier to propagate the beam across that area, and the energy that is output and energy and beam quality on the target is the key, really energy on the target. And General Greaves could teach a PhD dissertation course in this, so perhaps I should defer to him on it.
Senator, let's see, the main constraints or challenges have to do with power on the target, as well as beam control to ensure you can stabilize it, as well as pointing the laser in the right direction. So those are the major challenges we're working on right now. The scaling effort is one that has the most priority. The original lasers that flew on, the airborne laser, for example, they were chemical-based, so they were huge. They took up lots of room. Right now, we're working with 3 industry partners and with labs, the national labs, looking at electric lasers. Fiber-combined lasers is one of the technology. The other technology is, forgive me for the acronym here, but diode pump alkaline lasers. We've seen significant progress with both of those, and we're shooting to essentially move up from about 30, 40 kilowatts. For us, within the missile defense area, 1 megawatts high power. That we need that to go against
If you have 1 megawatt at the source, what's the delivered power to the target?
we need 1 megawatt at the target.
So what I'm looking for is what's the differential? How much, in the electric business I used to be in, we talked about line losses. What's the differential between where it leaves and where it hits?
Sir, it depends on the altitude from which the weapon is fired. We're looking at above 55 to 60,000 feet to get out of the atmosphere to allow maximum power on target, energy on target. I missed the second part of the question.
Well, in order to put a megawatt on the target, how much power do you have to have leaving the source? Megawatt and a half or 2 or 1 and a...
I may have misspoken. We need a megawatt capability at distance with line loss to affect the target. I'm sorry about that.
Okay.
But I know less about this than General Greaves. I think the answer, Senator, is that it's highly dependent on several variables. The degree to which the beam quality from its emission at 1 megawatt and your ability to control that and change its optic over time. In other words, it's not like electricity transmission, it's a constant, depending on what your sensor is telling you about how this very dynamic environment with water and air is moving, and you sense that, you change, like with a contact lens changing its prescription over time, what you are putting out. So it's a highly complex set of variables to say it depends on many of the qualities of the system, how much line loss essentially you have. Would that be accurate, General?
Yes, and what I'll say, sir, is while we were working on the successful mission, within the last 3 weeks, we've been doing some testing out on White Sands against representative objects out there, but at much, much shorter distances, and very successful in penetrating threat representative articles
Can I be assured that this is a major area of research and development and effort? It seems to me this is an enormously, potentially important development.
Sir, within the Missile Defense Agency, it absolutely is. And that's why we continue to have 3 activities going on in that area and request funding for it.
Thank you.
And Senator, if I could and add on to that, that's a major priority within the United States Army. So we've had some success, a lot of success recently with integrating a 10 kilowatt laser into a Stryker combat vehicle, where it is totally self-contained within that vehicle that will be able to maneuver with ground maneuver forces. And while 10 kW may not sound like a lot, what we've done over the past few years is grow it from a 2 kW to a 5 kW to a 10, and our roadmap is to put a 50 kW onto a Stryker combat vehicle within the next 4 or 5 years and be able to provide that to the ground maneuver commander. What we envision using that for is we've already demonstrated successfully against unmanned aircraft systems, and we've actually had soldiers actually operate the system when it was a 2 kW, 5 kW, 10 kW as recently this year, and we envision that in the future. So that's allowed us to have warfighters using the technology at a very early stage so that we can start developing our techniques and procedures that we will use in combat. We're on a path to get 100 kW high-energy laser as part of our IFPC Increment 2, our indirect fire protection capability in the Army, which will be responsible for fixed and semi-fixed defense. And we envision that it's going to be designed for not only UAS, but also counter-rocket artillery and mortar. And we've already demonstrated some success with a 50 kW against rockets or against artilleries out in White Sands Missile Range.
I foresee a handheld UAS anti-weapon staffed entirely by duck hunters from Arkansas. Thank you. Thank you, Madam Chair.
Thank you.